Alright guys, here we go. Let's take a look at the second part of this video. Again, if you have any questions, and as soon as you have questions, email me while I'm out of town so I can turn around and get back to you for Friday so that I can keep you up to date and answer those questions that you might have that the video doesn't clarify for you. Alright, here we go. Find the sum of an increment. Find the sum of a geometric series by hand or by your calculator if you know how to do it. So it's a geometric series. It's not an infinite geometric series, but we're finding the sum. And you need to remember that we have this formula, S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. So let's start putting stuff in and see where we get. A sub 1 is 240. 1 minus r, which is 1/2, to the n, which is 7, and then 1 minus, excuse me, 1 minus 1/2, then put in parentheses for emphasis. And this one's kind of nice, actually. We have all the parts, so we just need to calculate it. So we get 240 times 1 minus 1/2 to the 7th power, which is going to be 0.9921875. That's a long decimal, over 0.5. And then we just go ahead and calculate that. S sub 7, S sub 7, or the sum of the first 7 terms, is 476.25. On to the next one. Alright, so we're given a series and we want to find the sum of the first 60 terms. That means n is going to be 60. But first we need to identify, is this geometric? Is this arithmetic? What is this? If you notice, we're adding 3 each time. So that's arithmetic, and so d equals 3. So because it's arithmetic, we need to remember that we have all of this good stuff. We also have this good stuff to use. Those are 2 formulas that we're just going to need to know. So then, okay, let's turn around and stick stuff in. We need to find the sum, so let's stick stuff into the sum formula. We know n is 60, a sub 1 is 4. Uh-oh, we don't know a sub n. That's an issue. We don't know what the 60th term is, so we need to turn around and see if we can figure that out. We're going to use the other equation to see what we get. A sub 60 equals a sub 1 is 4 plus 60 minus 1 times d, which is 3, and that's going to give us our calculation for our 60th term. So our 60th term is going to be 181. So we're going to turn around and substitute that in here. 181, so 4 plus 181 divided by 2, then times 60. It's going to be 5,550. It's going to be the sum of the first 60 terms. So S sub 60 equals 5,550. Let's go to the next one. Find the 10th term in this sequence. Oh, interesting. First we need to figure out is that what the pattern is. See where we go from there. So let's first check to see if it's arithmetic. So 12 minus 5, so we go down by 7. So that's a minus 7. Do we go down by minus 7 again? Okay, we do. So then we can assume that we keep going down by minus 7. Now I want you to use the closed form to set this up. If we want to find the 10th term, we're going to put the first term in there, and then it's going to be 10 minus 1 times d, which would be negative 7. Once you use the formula to calculate it. Remember, we had that gentleman's agreement saying that you will use the formula to calculate it, even if it's something like the 10th term, and you can just find it. Keep following the subtracting 7 pattern. But I want you to model it using the equation and get used to being fluent using that equation. If not, I'll just make that, instead of the 10th term, I'll make that the 1/1,000,000th term, and that'll be annoying for you. But I can force my hand if we need to. Alright, on the next one, we're finding the 10th term. That means n is 10. So we get 5 over 12. That's it. 5/12. Sweet. 10th term is 5/12. Next one. Write a rule, closed form, for the following sequence, and then find the 115th term. So let's see what kind of sequence it is. Oh, look at that. Are we going up 4 each time? Sure looks like it. That means our common difference is 4. That means our first term is 3. And our common difference is 4, and we're in good shape. So rule, so a sub n equals a sub 1 plus n minus 1 times d. we want to write the closed form, so we're officially going to set this up. N minus 1 times d, which is 4, and we're going to simplify. A sub n is then going to equal 4n minus 1. So that's going to be our closed form. Then we're going to find our 115th term. We're going to put 115 in for n and reduce it. And you get 459. Fantastic. Let's go to the next problem. Find the sum of the series. Interesting. So it's not an infinite series, so it ends. What you'll notice is a sub n is going to be 8192. We don't know what n is for that last term, however, even though that refers to our last term. Our first term is then going to be 1/8. We want to find the sum. We got to figure out what type of series this is, and it looks like we're multiplying by 4 each time to get to the next term. So then that would mean that the ratio, the common ratio, is 4. So we get this, that, and that, and let's see what we can do. So sum of the first n terms of a series, geometric series, is going to be a sub 1 times 1 minus r to the n all over 1 minus r. We're going to substitute some things in there. We want s sub n. We don't know what n is, so that's going to be an issue, but let's just keep going until we get to that setup point. So 4 to the n, we don't know what that is, what n is, so then it's 1 minus 4. Okay, let's figure out what n happens to be. To do that, we need to take a look at other things we know about geometric series. We know that the closed form of a geometric series is this. So let's start throwing some stuff in there, see if we get any further. A sub n, we know it's 8192. A sub 1 is 1/8. Oops. R, we know was 4. And then to the n minus 1. Is that right? All right, let's see if we can solve this for n. Now, we can't multiply 1/8 times 4 because that would screw up order of operations. But what we can do is multiply both sides of the equation by 8, and we will then get rid of that fraction, that 1/8. So then we get 65,536 is equal to 4 to the n minus 1. Now, if you realize we have an exponent, we have a variable in our exponent, and that's an issue. Remember, to get that out of the exponent, we have to use logarithms. So we're going to go back to what we did in Chapter 8, 2 chapters ago, to try to solve this. I'm going to log base 4 on both sides, and that's going to be the inverse of a base 4. So that's going to eliminate on that right side. So we get log base 4 of 65536 is equal to n minus 1, and I'm going to add 1 to both sides. So we get that expression. We can't add these two, the 65,000 and the 1, because the 65,000 is in the argument of that logarithm. But if you remember, if you don't have math print and you've got to do logarithms on your calculator, you have to use it using common logarithms. So we used log base 10, which is the button in our calculator. So we're going to calculate that, and then we're going to add 1 to it. I'll show you how I type it in. All right, so let's take a look at, let's type this in here. We're going to do log of 65536, parenthesis, enter, and we're going to divide that by the log of 4, enter, and then we're going to add 1. So we get n is n equals 9. So n was 9, so we're going to substitute that back in. S sub 9 equals 1/8 times 1 minus 4 to the 9th minus 1 minus 4 over 1 minus 4. So that's going to be 1/8 times 1 minus 4 to the 9th is going to be negative 262,143 over negative 3. And we're going to multiply that out, and that'll be our answer. S sub 9 is going to equal 1/8 times negative 262,143 divided by negative 3. It's going to be 1092.2.625. So that will be the sum of all of those terms. Alright, now on this one, rewrite using summation notation. If you remember, summation notation has the E. We need to figure out the closed form, and that's what we end up writing in here. We start, we're going to start at n equals 1, and we've got to figure out what that last term is on where to stop on summation notation. So each time it looks like we're adding 3. So that means the common difference is 3. From this problem, a sub 1 is 7. A sub n is going to be 65, but we're going to need to find out what that n is. But before we do that, let's first write the closed form. So we're going to get a sub n equals 7 plus n minus 1 times 3, which is going to be a sub n equals 3n then plus 4, and that's what's going to go in right here. And then we got to figure out what term number n is, or the last term in the series. So we're going to substitute 67 in for a sub n and then solve it for the variable n. So we're going to do 67 equals 3n plus 4 minus 4 from both sides. 63 equals 3n. Then we wind up getting n is 21, and that's the number that we write up here. So our final answer is the summation of n equals 1 to 21 of 3n plus 4. That's our answer. So let's take a look at the next problem. Find n for the given sum s sub n for the arithmetic sequence when s sub n equals negative 138. So let's see what we can get from this series. So, well, we know a sub 1 is that. Sure looks like we minus 3 each time, so d is negative 3. And we have this information. So let's package that and see where we go. We know that the sum of an arithmetic sequence is s sub n times 8 plus 1, or 8 sub 1 plus 8 sub n over 2. And let's start filling in some stuff that we have. A sub 1 we said was 5. A sub n we don't know. That's interesting. And nor do we know what n happens to be itself. But we do know what s sub n is, so let's replace that. That is negative 138. Alright, this is going to get interesting, isn't it? So we got to figure out what a sub n is, and we got to figure out what n is. So let's take a look at what it is. So let's see if we can go to another formula that we have, which would be this. So let's start subbing some stuff in and see where we get. So 5 plus n minus 1 times negative 3. Distribute and simplify. We get negative 3n 8 plus 8. Very good. Okay, that gets us somewhere. Let's take this then, and we know that those are the same, so we're going to replace it in there. So in here, we're going to write negative 3n plus 8, and then we're going to see if we can simplify that. We only have one equation, and we only have one variable, so we're actually in good shape. So let's simplify the numerator before we get messing with the fraction. So then let's do 8 plus 5 is going to be 13, so negative 3n plus 13 over 2. Now what I'm going to do is I'm actually going to distribute that n into the numerator, because that looks like it'll help us out. Alright, now let's get rid of the fractions by multiplying both sides by 2. Multiplying both sides by 2. So we then get negative 3n squared plus 13n equals negative 276. Very good. And now this is a quadratic that we can solve. I'm going to move everything to the right to make sure that leading coefficient is positive. And it doesn't look like we get any good news from that, actually. But what we can do is we can let's see if we can factor that, and if we can't factor that, we're going to see what happens here. So we turn around and factor that as 3n plus 23, and then n minus 12, and you get two solutions. N equals negative 23 thirds, and n equals 12. Now the first one is actually extraneous, both because we can't have a negative term value, and we can't have a fraction as a term value or a decimal. There's no like 2.5 fraction. So our answer is n equals 12. Woohoo, we did it. That was a tough one, but I think you guys can handle it. You're pretty good. Again, at the end of this video, email me if you have any questions right when you get them, and hopefully I'll be able to respond as I'm working through the conference I'm at. Great. Have a good day. I'll finish the rest of the problems in a bit.